Hi everyone. So good evening. So today I am going to talk about the extended statistics in PostgreSQL and how they impact the behavior of the planner. So the quick agenda, like why to create the extended statistics. So whenever you create a table and load some data into it, or you do some updates or deletes in it, usually there is a maintenance process which runs by the auto vacuum daemon. We call it as the analyze. Basically, it collects the statistics around that table. So whenever we run a query, so the planner takes the decisions based on the statistics which are available in the database. So, and I will go through the criteria, and then I will go through a quick demo of the different queries and how they behave with and without the extended statistics. So why to create the extended statistics? So basically, like whenever, as I said, the analyze maintenance process, it collects the statistics, right? But it collects the statistics of a single column within the table. So whenever you are running a query with the multiple columns, the planner is not aware of that correlation between the columns which are present in the query. So that is why in some cases, based on our experience and the testing, we may need to create the extended statistics to improve the planner estimates. So I said, so criteria, it's like we need to see like whatever the columns, those are included in our query. And we need to make sure these extended statistics are created on those columns. And also look at the high cardinality columns. Cardinality is nothing but the columns which are having highest number of the distinct values. Okay. So I would go through the demo now. If you see here, I have a select query on the sales data table. And I have only one condition here, where the product ID is equal to 2. If you see here, the planner is estimating around 99K rows, whereas in real time, it is pretty much returning 100K rows. So the estimates are close enough. But if you have a look at the next query, so I have the query which contains the 2 columns after where clause. And you can see here, which I highlighted in red box, if you see the planner is estimating only the 20 rows here. So we can call it as the rows are being underestimated here. So how to get rid of this problem? So for this, we need to create the statistics. So we call it as we can create these extended statistics using the create statistics statement. So I have created the statistics on the 2 columns which I am using in the query, and then I analyze the table so that the stats gets collected around these two columns. And then I rerun the query. If you see here, the planner has estimated around 19K rows, and which is close enough. So this is about the select query. I have the other query which is aggregate. So if you see, like when I'm using the aggregate here, the rows are being overestimated here by close to, I think, the 100 times. Yeah. So here I decided to create the other types of statistics. We call it as n distinct stats, and then I'll analyze the table. And I rerun the query. If you see the planner is now, it looks good now. So like when these extended statistics are not useful, like if you have the join queries, right now the Postgres is not supporting the extended statistics for the join queries. So you need to test them, and if you have the a join query and for which the planner is going out of estimates, make sure you try to rewrite the query. So that's my 5-minute talk. So thank you.